Welcome to this podcast where we'll discuss the principles involved in how to locate the plane director of a hyperbolic paraboloid. So we'll begin by just looking at a typical example of a hyperbolic paraboloid. Here we can see over here we have the surface A, B, D, and C, and here we have the elevation and plan of the same surface. So what we'll do first is we'll just discuss what the plane director is and how it's used to help generate our surface. So if we take a look at our 3D view here, we can see we have the boundaries A, B, BD, DC, and CA, and they make up the boundaries of our hyperbolic surface. So if you remember, our hyperbolic parabola is basically created by taking a generator, so in this case CD, and moving him along two linear directrices. So they're the lines BD and AC. They are linear directrices, and they act as guide rails for our generator DC. So DC moves along our two directrices, and as it moves along, it generates the surface. Now, where our plane director comes into play is that our plane director fixes the type of shape that we're going to get. If we take a look at our generator here, CD, if you can imagine just having our generator and our two directrices, well, it doesn't give us a fixed shape. I could take the point C, and on my generator I could move him along at a different rate to point D. So I could move C all the way along the end here and not move D at all, and that would give us one surface. I could do the opposite. I could move D and not move C, and that would give me a totally different surface. So what our plane director does is it fixes the type of shape that we end up getting. So if I have, say, a steeper plane director, it will give us one type of shape. If I have a slacker or a shallower plane director, it will give us a different shape. So in some senses, tightening up the shape, making it stiffer or slacker. So that's the function of a plane director. It fixes our shape. So if we just look at it here in our 3D view, this is essentially what we're doing. We're just sweeping along our generator, creating the surface. Same thing applies over here in our elevation and plan. Our director moving along and our generator attached to our guide rails, generating the surface. So if we just take a look at what we're going to start off with, then when it comes to locating our plane director, we're going to locate the traces of our plane director. The traces being where our plane director crosses the vertical plane and where it crosses the horizontal plane. So what we normally start off with is the boundaries of our plane director. So just the outer edges, like so. One way to think about it, I suppose, or probably the most useful way to think about what we're starting with is we're essentially starting off with a starting point and an ending point for our plane director. So in our 3D view here, you can see CD is the generator in its starting position, and this is the plane director containing it when it starts off. Here we have AB, which is our plane director at the end of its path. So there's our plane director at the end of it. So we have a starting position here, likewise over here in elevation, and we have an end position here. So the idea being behind that, our plane director has a starting position and an end position. The idea there is that our plane director must contain both those lines. So it must contain our starting generator, our finishing generator, and we're using that basic principle to determine the plane director. Just a little bit of a background on that. If you have two skew lines, which is what we have here with our two generators, two skewed lines, they're lines that don't intersect and aren't parallel to each other. If you have two skewed lines, there's always one plane that has the ability to contain both of them. So in our case here, that's what our plane director is. So how we go about generating or creating our plane director is by simply taking a copy of our, say, end generator here. So if we take this as our original generator here, if we take a copy of that and attach it to either point on our starting generator, so we'll just do like so. So I could pick the point C, I could pick the point D. It really doesn't make any difference at the start, as long as we follow it through from our elevation to our plan view. So that line is on our plane director, and that gives this plane the ability, as he moves along, to contain the copy of the original one when it reaches the end of its path. So we'll do the same thing in both our elevation and plan. So there's our copied line in elevation, our copied line in our plan view. And what you'll notice is that our copied line, because it is the same as the original one, it will appear parallel in all views. So it'll be parallel to our generator in elevation, it'll be parallel to our generator in our plan view. The next thing we do then is we draw a horizontal line along our plane. So our line here is horizontal, it's level. You'll notice that it's parallel with the traces, the horizontal trace. And the simple reason being is that our horizontal trace is a horizontal line on the plane. Our sample line here is also horizontal. Any horizontal line on our plane is going to be parallel to the trace. So we'll go over here to our elevation, we'll repeat the process. So from our second point on our generator, we'll draw our level line, so horizontal. There's our horizontal trace in elevation is a level line, so it's parallel elevation. And when I bring that down, where it hits my copied line, I connect it back to D. There is our level line in plan view. It's now seen as a true length, and it's also parallel with our horizontal trace. So if we take, say, back to our 3D view here, now we have a line parallel with our trace. In order to locate the trace, we need one point on the horizontal plane. So how we do that is simply by taking our generator CD, we just continue him along the plane until he hits the horizontal plane. So over here in elevation, we'll do the same thing, and here's our point where it hits the ground, our horizontal plane. We take him down into our plan view, and we just continue the line CD. So this here is our point on our horizontal trace. So if we have a point on our horizontal trace, we also have the slope, or the angle of our horizontal trace, so we're able to draw in our plane. So here's our plane, and here's our horizontal trace. What we need to do now is locate our vertical trace. We already have one point. This single point here is one point on our vertical trace. That's where our trace hits the vertical plane in plan view, so our back wall, if we care to call it that way. All we need now is a second point. To locate our second point, we go back over here to our 3D view. If this level line here is parallel with the trace, any level line on our plane is going to be parallel with the trace. So if we take our point C here, we draw a level line, so it's parallel with the trace, the horizontal trace, and we can repeat the process here in our plan view. So from C, where we're going parallel to our trace, where it hits our vertical plane, well, that's a point on the vertical trace. So you can see here it is here in our 3D view. This is our point on our trace in our plan view. We project it up into elevation. We take our level line across, and that locates us our missing point on our vertical trace. So we can draw in our plane, and now we have completed the traces for our plane. And you can see here, that's when it's in the position containing the line CD. In each of our questions, we'll generally be told that we want to be given it in a particular position, because as you can see from your 3D view, our plane itself can be any number of positions, and it can contain any one of our generators here. So we have to be told what position we find it in. Otherwise, we're just finding it in a random position. It's still the correct plane, but it's not in the position that we're after. So that's the basic principle behind how we locate the plane director for a hyperbolic parabola. Hopefully it's been helpful.